Hey everyone. Um, Welcome to another episode of the Common Lisp Study Group. I'm your host, Ron Vadum with Atlanta Functional Programming. We at the Atlanta Functional Programming Meetup have a mission of kind of showing people, not only how to use functional programming as a dominant paradigm, but with respect to Lisp, we're willing to take requests and you know highlight projects or show how to set up different things for Common Lisp for your convenience, so you can actually get up to speed on writing, Common Lisp. There was a request from one of our viewers on showing how to use Roswell. So today, I thought it would be great to actually go through that process. For those of you who aren't aware about Roswell, Roswell is a implementation installer and manager for Common Lisp. You could think of it kind of like a unifier for running different Lisps in a single environment without having to deal with kind of the quirks of the package manager of the host operating system. Because let's be honest, for certain package managers, especially if you're using Linux LTS, it might be the case that a new release, stable release of Common Lisp may not actually make its way into the package manager um, immediately. And Roswell at least has one of these advantages where as soon as some things are available, almost as soon as it's available, you can almost be sure that it's available to get installed via Roswell just by simply saying either ROS upgrade or ROS install. But I'm not, dismissing the package managers. I just know because of the package manager time it takes to actually create a proper package to get installed through those individual package managers, whether it be Debian or through its deb packages or Red Hat through RPMs. There's a little bit of quality assurance that needs to be done. But if you want to really get your stable things going, and more importantly, if you want to be able to move your code in a portable way and provide people instructions to actually set it up, kind of like the same way as Python virtual env, Roswell is here to handle those cases and much more. So I'm going to go through an actual installation, even though I do have Roswell installed on my box here, just so that folks can actually see kind of the process on how to install it. In the case that you may not have Roswell available in your package manager of choice, so that is one thing I am kind of uh, uh, I was not entirely honest in that to install Roswell, at least for different operating systems, you do have the ability to um, get it from your package manager if you want to. On Homebrew on Mac OS X, you just simply need to do a brew install. On Linux, you have it available on Arch through Yay, on Void through XBPS, Gentoo through emerge, as well as on I think in Debian there's a way of doing it through apt-get. The way I actually end up leveraging uh, and grabbing it is through the following. And to show this, I'm going to first set up a Docker container just so that we can actually get something really useful going here. And just make sure I don't have it there. All right. So let's go ahead and do a Docker run it dash name test ras Ubuntu Jammy. Jammy is the latest version of Ubuntu, and we'll just start up bash so that we can actually. Oh, so we just do this Docker test ras because I was trying to do this earlier. Okay. All right. So the way you can actually grab this is through curl actually, and let's just make sure curl is available in our command. So let's go ahead and install curl this just so that we can actually. Oops, let's do this update. Okay. Let's do this. This is just me doing a kind of a throwaway setup here, but for folks who actually want the setup in a container, I will be more than happy to set up a Docker file for you guys to actually get this working through to Linux for your own needs. Just put your request in the comments, and I'll get to it as soon as I can. Let's make sure I have also one more thing that I need. Let's go ahead and just grab this one. So for folks who are following along, the commands that I'm showing you here, if these don't make sense to you, I got these available from the actual Roswell installation link that's available on the website roswell.github.io. You can actually see that in the YouTube description. I encourage you to go through that to actually set it up for yourselves. And there's additional information on there, some of which we'll cover today, some we may not be able to get to, related to like continuous integration that might be useful for you at some point. So once we grab, so what I did was I grabbed kind of the last stable version of Roswell, and uh, this is the Debian package that may or may not end up showing up in some distributions for Debian, but you can actually see it available through the maintainer's website. A lot of the folks end up using Debian distributions on the project, and they end up managing a lot of these tarballs, and they get up to date fairly quickly. So you could just grab the Debian package directly from the Roswell website using curl, and once you do that, you could just simply run dpkg-I to actually go and install it. See something here? Oh, my apologies. I have to go install libcurl3 plus and bzip2 as well. And let's see if I can do that. Set this up. And we may need to also install GCC2 as well. But we'll see. Okay. And Roswell Debian packages are kind of like your normal Debian packages. They'll just go ahead and install it at the appropriate locations, update the path variables, and so forth. And when you run it the first time, what Roswell does is Roswell actually will grab the default version of a common Lisp. Usually it is sbcl unless you state it. But after we set up Roswell with sbcl, there are a bunch of other commands that you could use to actually um, try out different other common Lisp installations, whether it be ccl. I think it's there's also which is closure common Lisp. There's also armed bear is available through Roswell. There is also there is a couple of other, there's about I think 4 or 5 different Lisp implementations are available, including ECL, SBCL, like I mentioned, CCL I mentioned. Clasp is available too for those of you who are doing C++. And in Common Lisp, it's also available at your disposal. You don't have to go and compile it yourself. And I'll show you how to actually, I think there's, if I remember correctly, there's a way to actually go and look through Roswell to actually figure out in what places you can get stuff. After it goes and installs SBCL and sets things up, it actually goes and downloads Quicklisp for you. It looks like there is an issue here, and it is related to. Okay, this is the issue that I had with the last stable version. Just look at something. List installed. Oh, that's the problem. Let me do this. Roswell install with Quicklisp. Quicklisp needs a newer version of sbcl, and unfortunately by default sbcl 204 is what it's using right now. I need to install, if I remember correctly, sbcl 2111. This all set up. So just give me 1 second here. sbcl bin. This is a known issue that they're going to be fixing in the next release. It's just for the time being, it is not available. So let's see. Let me go ahead and let me remove delete sbcl bin 2.0.4. Okay. And let's make sure I can actually let me do let's see what happens if I do a ROS run. Okay, so ROS run works. Let's get ROS install. I don't think this is necessary, but it looks like it's complaining about this again. I had this one issue at one point in time, but for some reason it's complaining about it again. Give me just a second. What was the command to actually go and set this up? This was we need to do ROS install this is okay. You know what? When we get to it, I could show this to you. In Roswell, once you actually install the basic thing, it will go and attempt to install Quicklisp. I think it already did this already in this case, but you know, it was complaining about something in the case of using sbcl it's version 2.0.4. But there's a way of actually fixing this by just simply doing this 11. And we're changing the default implementation, and now we can actually go and delete the old version, and this should fix everything. Do it this way. Time. This and ROS, what was that, update? Quicklisp. Let's see what happens here. And let me just do this ROS run. This is going to be, what was it? What was the command again? This one is Lisp implementation version, I think is what I'm looking for. Okay, so this is still running 2.04. That's not what I wanted. Let me go ahead and say use sbcl-bin 2.111. Let's install. Everything should now be there. Okay. Let me make sure that I could do this. So now let me just make sure I can actually quick load something here. Okay, Alexandria. So this is now all working. So, although Roswell internally needs to run with 2.04 just temporarily, like I said, this is a known issue that's in the Roswell GitHub issues. Last time I checked, um, to work around it is once you've installed Roswell and you get Quicklisp installed and you get all your um, basic necessities installed, it will actually you can actually change the Lisp version like we just did earlier, and just say use a new different Lisp and everything works out just fine. You can actually go ahead and use it. Um, for whatever reason, when I'm running it in this container, the delete didn't seem to work as I planned. But I think there's a couple of extra steps that I'm missing there that again is a workaround, but it's going to be fixed when you actually when the newer version of Roswell comes out. So I really don't want to get into giving you guys a workaround when it's already kind of something that is going to be fixed in the next release. Okay. As you can see here, once you have Roswell installed and you have your your Lisps installed, it's pretty simple now to just use your Lisp environment as is. But many of us don't really want to just use uh, the REPL has we usually want to hook it up into some sort of IDE, more than likely some sort of text editor like Emacs, and there has to be a way to do that. So for the Emacs users out there, Roswell provides both um, connectors for Slime and for Sylvester or Sly. So all you have to do is just to install Slime or Sly. You just need to type in the appropriate thing, and it will go ahead and set up from GitHub, grabbing the appropriate uh, uh, um, tar files, uninstall it, and give you what you need to do to actually set up your Emacs file. All right. The same thing actually goes with Sly. Although I'm doing both here, this isn't actually necessary. You don't want to actually do this. Pick the one you feel appropriate, because you'll get this kind of error. Um, and again, um, uh, when you do use one or the other, set up your Emacs file appropriately by just adding this helper file, and you can go through it, and you'll be okay. Um, Let me go and actually, let me delete Slime and see what happens here. And you have Slime installed. That should not be giving me that. Hmm. Let's see if says that it can find it. Ah, it is already there. Okay, weird. All right. So we have our Emacs environment all set up, and we have Slime installed in this case, although I use the Sylvester command, and I kind of showed you what that command is. The next thing to do is kind of wonder, well, that's all well and great. What does it buy me if it's just only installing, sbcl? And when you look at Roswell, you can actually list various things. Uh, and each command has its own set of subcommands. So in this case, what we're looking for is not list of installed versions like I showed you earlier. List installed will tell you what you already have on the system. You can actually figure out what is available through Roswell by just typing in list Roswell or Ros list versions, and you can see what's available. You can see several are available. For those of you who are looking at Lispworks and Allegro, those are for the Express versions. That is the free versions of the commercial Lisps, Allegro, Common Lisp, and Lispworks, respectively. If you end up having, a commercial Lisp already available on your system, um, you don't necessarily need to use Roswell to actually go and deal with it, but there's a way to like kind of hook it up so that it recognizes your commercial list. Unfortunately, I'll be honest with you, I've never actually um, tried that myself, so I'll um, I'll leave that exercise to the viewer who's watching uh, the Roswell's uh, who wants to actually use Roswell for that particular use case. Um, uh, Before I continue, there is um, there is a couple things I want to kind of mention related to some of the lists that are in this list. Okay, um, in particular, SBCL and SBCL-bin. All right, um, with SBCL. SBCL by default is, I think, the older Steelbank Common Lisp like setup to actually install Steelbank through Roswell. For all newer implementations, you're going to have to end up using SBCL bin. I don't believe you can use SBCL to get newer versions, just because I've had some issues in the past dealing with it. Additionally, for those of you who are looking at Armed Bear, which is the top of the list there, ABCL-bin, you need to check, and it would probably be best to check the version of Java that you end up that you have installed on your system, because I think the um, the uh, version of Java that I think newer versions require is at least Java 1.7 or later. So I think that is important to know. I think it's actually Java 1.8 or later, the last stable version. So most of them should work with at least Java 11. I haven't tried it with the newest version of Java, but I'm sure, provided there's no deprecated, like major deprecation on some APIs and implementations, ABCL should work on most newer versions of Java, but your mileage may vary. Clasp is another thing that I wanted to mention briefly for those who are looking at Clasp and haven't had a real chance to use it. Um, with Clasp, there the release cycles of Clasp and when it gets into Roswell is still unknown to me, but you can almost be certain that the latest stable version should be in Quicklisp pretty as soon as it can be. Um, what else did I want to point out? Oh, I think it's the other one with MPT. So MPT is just a utility. If I remember correctly, it's just a utility. Yeah, just one second here. Just looking at my notes. Let me just double check here. Um, okay. There's a couple things in here that are tool based, like MPT, I think is a tool. As you already seen the list there, ASDIF, Sly, and Slime are all tools that can be accompanied on top of Roswell. ASDIF is particularly important because ASDIF is usually installed with your common Lisp, but it doesn't get up to date as quickly as the release cycle for the built-in ASDIF that's in your Common Lisp implementation, that's usually run with your Common Lisp implementation, is older than the ones that are available in Roswell usually. Roswell will install the latest version directly from GitHub onto your Common Lisp environment. This is one of the reasons and advantages of using something like Roswell, much like using virtual env if you're coming from the Python space, because you want to be able to at least get the foundational libraries and up to date when you're setting up environments so that your developers can actually go and use the latest stuff with regards to the underlying build system, which ASDIF is a part of almost always nowadays with when it comes to modern Common Lisp development. So just keep that in mind, and we can if you have any questions, feel free to post stuff in the comments, and I'll get back to you. Okay, so that's it for the installation. Feel free to post questions on the live stream chat, and I will get to them as soon as I can. But in the meantime, I thought it would be useful to at least show uh, a couple of things with Roswell that I've personally used it for, and also some stuff that I started looking into just merely because recently I found out it was available now inside of Roswell, but I haven't had a chance to actually play around with. You know, time permitting, we might get a chance to at least get started on a couple of this, but we'll certainly make another episode so that we can go through it and do a deep dive into this stuff, particularly the stuff on using Roswell as part of your testing environment and part of your CI strategy if you want to hook it up into a continuous integration server, whether it be GitHub Actions, Circle CI, or Travis, which is the supported ones that are available in um, Roswell as is. And you can see more of this inside of the documentation if you go to roswell.github.io. So I mainly use Roswell for my for three things. One, to set up my Lisp environments so that way I can actually uh, not have to worry about the my host manager or my host operating system not having a particular version of Common Lisp, because I can actually easily get it from Roswell. The other thing I do use it for is scripting, and there's a couple things that you can do for scripting that would be particularly useful. For starters, let me just make sure I could do this. We're going to make a quick project in my list projects called EFP. Right, this is just going to be a fact program, right, that we're going to just create, right? And we'll go in here and we're just going to create Ros our fact programs using Razinit. Razinit, if you look back at Razinit at the top there, it will allow you to create a new Ros script based on a particular template. Now, if you want to see help on that, you can actually do Ros help. I think Ros help init or Razinit, I think is actually what I need to do. Ros help init. Let's see what it does. So um, the Razinit function allows you to provide um, a a template file if you so choose. By default, the template file actually looks something like the one that's shown below, where it sets up your shebang environment using Bourne shell, sets it up so that it will actually call out to Roswell, assuming Roswell is part of your path, and then it will set up your environment, and kind of things like ensuring that ASDIF is already installed and so forth. We're going to go and look into this a little bit more detail when we're building our program. But the reason I wanted to bring this up is there is ways to update this default script by creating these templates yourself. if you wanted to for different sort of things. You could think about and we'll see this in a minute. If you wanted your scripts to being having certain libraries available, you could certainly do that, and we could do that in a second here. So let's go ahead and create our first script. All right, and let's fire up emacs here. Fact.ros. Okay, so first things first. In the prog and where we're initting forms, you may notice this hash plus Quicklisp. Hash plus Quicklisp checks to see if Quicklisp is available when you are compiling this Roswell script. Okay. Obviously, when you're using Roswell itself, it is safe to assume that Quicklisp will be available. If not, but there is a chance that it may not be. If it is available, you could actually use this command to actually install um, various third-party libraries that might be available, or have Quicklisp download it for you when you are generating, when you're building in your images and executables. Okay. This is another way I use Roswell too as well. When you're creating a sophisticated application with multiple ASDs and so forth, you can use this Roswell script as a kind of like a make file, and you can use Ros build to actually build out an executable for you. We're going to use Ros build to actually generate a factorial executable here for simplicity's sake. But I do want to mention that this is another way for you to use Roswell in case you don't want to go and deal with your what's it your underlying Lisp implementations way of writing portable common Lisp. You could write actually a script to actually handle it, and just make sure that in your common Lisp use the appropriate portable API calls so that your code can actually work on across multiple Lisp implementations. Let's just go ahead and set something up here and deal with the next case here. Uh, Okay, so let's first build up our simple, factory factorial program here, right? Just to kind of show how this kind of works. So obviously, the best way to set this up is I'm just going to write the naive approach of actually building this up. We're just going to go ahead and write this uh, recursively. If we 0pn, obviously that means we're going to be returning one. Otherwise, we are going to be, returning fact one. Okay. So here, and obviously we need to make sure that we do the proper steps here. You could say ignore this or what have you, but really what you'd want to do is um, provide a command, an argument here. It's the first command here, and um, actually, let's not. We can actually do it this way. This is probably a better way of doing it. Okay. Mm, it's fine. So here, what we'll do is we'll just go ahead and deal with if null n. Let's go ahead and print our usage fact number. Otherwise, let's go ahead and call format key a percent. And the newcomers coming in, tilde A's are for formatting expressions that are being passed in as arguments into format. This is kind of your printf. Tilde percent is actually just creating a new line at the end of your thing. In fact, technically, we don't even need to do this since we know that these are going to be integers. We can actually make tilde d to actually make it so that they're fixed nums. And we could just go ahead and do this. Parse integer. All right. So let's get this going. Let me start up a shell. Let's do a ROS build fact. Oh, let's have it. Oh, ROS build fact ROS. And what ROS build does is it will actually go and attempt to compile this and make sure that it will run it, and it'll create us our little executable here. And obviously, if you run this, you could see, oh, this actually does not. This will actually make things. So if I actually go ahead and send this, this will this up. What? Let me do it this way. And this one works. Okay. Let's do this. If 0p length b. Okay. And oops. One thing. I'm just grabbing the first element of this guy. ELT. I think it's RB0. If I remember. Forget some things here. Yeah. Okay. Oops. Let's do this. I forgot one more thing in here. X DELT argv0 and do this. Okay. And let's go ahead and do this here. This is X and save here. Just so that we don't even have to do that. Let's do this. Let's be clean about this. Do that, and we do X, and go ahead and parse the integer here. Integer ELT argv. Okay. All right. Okay, so we're good here. Let's just make sure. And it gives me the usage as we expected, although, albeit you cannot see it. So let me go ahead and do this. Let me switch over to another location and go to AFP ROS And let's do this. You can see that it properly sets up our usage. Um, Now, if we go and run, obviously 5, you'll get the appropriate command that we were expecting, which is 5 is 1. Now, this is all well and good. We're able to actually go and build, executables with this. But what if we want to run it as a script? Well, you can run it as a script as is. If you just do fact ROS, it's actually an executable script. It's just that there's a pause. You may have noticed a pause when you run this. Let's see this again. Okay, if I do fact ROS. And the reason why is there is a startup time associated with starting up your sbcl environment. Okay, so it's a small pause to actually go and run the script before it actually gets executed. So you can reduce that startup time by simply uh, doing a couple things. One, you can actually uh, reduce it by uh, doing the following here. Instead of doing this, you can actually go ahead and run this command, right? Which is the only difference is it's going to get rid of uh, the command that we just have. Okay, to illustrate this, I'm going to first do this. Let me just show you the time difference here. If we run time dot fact ROS 10, you could see that it takes, oops, let me do something here. Time ROS, exec not found. Oh, sorry. We run this, you could see that it takes, roughly like, zero point 0.7 seconds. And most of the time it's loading Quicklisp and sbcl, and it then compiles your program and loads it into memory by doing a quick load, and then runs it as is. Okay. If you want to actually compile speed this up, you can actually do exec ros plus q dash dash $0 or at. And what this does is it will actually load up your script without quick lisp. And we actually just get rid of this command here and do this. And you can see it went from what 0.818 seconds to zero point 0.2. So that's actually quite a bit of a speed up. Now think of this also when you are building fairly complicated applications, because in that case, the difference is going to be um, fairly significant. But if you are using a lot of third-party libraries, sometimes you can't avoid not loading up Quicklisp to compile your stuff. And this is where then dumping an image or dumping an executable comes to your rescue. Uh, we've talked about dumping executables before in this program in previous episodes. I encourage you to go and look at our episode on dumping executables using sbcl, where we talk about, remember, images are FASL files that can be loaded into memory. They're binary dumps that includes the Lisp runtime plus whatever necessary execution code to figure out where the entry point to your program is. And each Lisp is different in terms of what program arguments need to be passed into the function that it uses to actually dump the image. Like in the case of sbcl, and I think even cmucl still uses the same name, you can do something called safe lisp and die to actually go in and dump your image, and it will take all the running objects in memory of your running image, and it will actually then just write it out to disk. and it'll in the meantime, if you wanted to actually also start it up again, you need to specify it has a command line argument entry point. Now, with the case of Roswell, you don't necessarily need to know what your Lisp would do, because Roswell will take care of that for you based on which Lisp you are setting as your default version. It can actually go ahead and use that version's save Lisp and die equivalent and dump out an image for you. Does that make sense for folks? And again, folks who are watching the stream, feel free to ask questions. I'm more than happy to answer any questions that you may have related to Roswell and my experiences with Roswell as we go through this. I'm just gonna wait just for a second to get a quick sip here of water.
Hello?
Hey, Judd.
Hey.
Can you hear me? All right.
How can you hear me?
Yes, I can hear you now. You were kind of breaking up earlier.
Sorry. How much can be done to limit? I don't want to load up, like everything, right? Is there an organized way to trim, the tree to have just what I need loaded in order to do what I want to do?
Are you
to
asking
run
about
my
tree shaking of your Lisp executables, so your Lisp executables are small?
well, size to be, I can see perhaps there are exploits, right? So if we can count on everything of some list being loaded, perhaps there's an exploit, right? Does that make sense?
Yes, I know what you're
Just for
asking for.
security's sake,
This is this. I understand what you're asking for. So for folks who are just joining us on this conversation, the question being asked is there a way to actually limit parts of what is loaded already in the Lisp image? So when we write to disk or when we are building our Lisp images, so that we can limit the attack surface when a application is loaded into memory. So when an application is actually run. This is a particularly interesting and very important thing to be aware of. As far as I know, all right, and I've been really doing quite a bit of digging into this. Um, there is parts of the Common Lisp runtime that just have to be there when you are running an application. Now, unfortunately, I have yet to find exactly a command or way of limiting that attack surface when you're building your Lisp applications. Unfortunately, and this is kind of a and folks who are uh, more experienced in Common Lisp and building secure applications in Common Lisp, by all means chime in, write comments in the YouTube discussion, or just ping me about this, because I'd be more than happy to discuss it with you more. But as far as I can tell, like, with respect to the Common Lisp hyperspec, there isn't anything related to trimming down parts of the runtime when you are actually starting up your application. Like base Common Lisp will always be available. After that, there is whatever libraries that you don't want necessarily in the Lisp image. You could certainly, I think, prevent that from actually being loaded by simply with, at least with respect to Roswell, if you recall, if we just load them up and use Roswell as our build system, we could just simply load only those libraries that we need in the quick load and then dump out the executable when need be. Does that make sense?
Yes. Thanks.
Okay. I'm planning on doing a more extensive talk about this just because um, limiting the attack surface of common Lisp applications and being able to do that is a very important piece to be aware of. Just because obviously when you are dealing with uh, writing, especially applications that are running on the internet, it's it'll be very useful to be able to limit the attack surface when it's running in like a container up in the cloud somewhere. S- Okay, so there's a question in our chat. Does ROS support creating builds for different platforms? I know cross compilation has been very good a very good question. So there's a question about ROS supporting creating builds for different platforms. As far as I can tell, by simply just using the ROS script as is, okay? And they've been working their butts off to actually making sure that this works really well in as many platforms. I know for certain for Mac and Linux, even before, just because they're Unix based, it was working really well. But in addition to that, I have there is some notes on setting up like Lisp dev environments using Roswell on Windows. I encourage you to go and look at the Roswell documentation there that is on setting up environments on Windows. Unfortunately, I do not have a Windows machine to actually uh, demonstrate this at this time. But if there is sufficient demand on that, I can most certainly set up one so that we could talk about how to do Lisp development on Windows. But once you have just a Lisp installed on any of the platforms, Roswell using ROS build will make your life so much easier. You don't have to do much. It will just use Quicklisp in combination of Quicklisp and ASDIF to actually set up your builds. And in fact, again, although our time's limited tonight, I am planning on hopefully in a future discussion, probably next week, cover how to actually set up Roswell for testing using continuous integration, because that's something I saw in the Roswell documentation that they finally kind of got some of the kinks out that I can actually show off and kind of highlight. This is something that I've been waiting for a while because I've had some. I tried to do it myself, but it was a bit of a dirty hack when I tried doing it, and that certainly helped things. Other questions? With Roswell, it's just a script now. It's really beautiful. I think it's a this unifies many things. Another thing that I think is very useful is the ability of setting up uh, what they call installable scripts. So like once you set up a script, all right, and you think it's ready and you want to make it like a tool that's available for other users, you can actually set this up so that you could share it. And the way you do that is you you can actually um, add your Roswell file into a repository and then provide like a command line interface for Roswell to go and pick it up. And there's two ways of actually doing this. One way is actually through GitHub. You can actually just set up a way of building pulling stuff through GitHub. So let me just show this to you. Um, we have, let me just make sure I can show this set of, let me see if I could do rods install. Uh, yeah, I think it's just a matter of just doing this. So I could probably show this example. Hold on, I keep hearing discussions here. Oh, awesome. Wow. Okay. Give me a second here. So what I did was earlier, I wanted to try this particular thing out, and I think this would be really useful to show folks. And that is to just double check here. Okay, so let me just go into this. And let's see. If I just do, if I just do version 2.0 here, see something here. Set this up. Okay, we could try this up. So the first thing to do to set this script up for distribution, because we have an example script that we could set up for distribution, is to actually let's see if this will work. Well, let me first show you already installable scripts that are available through Roswell, and then we can build up this custom script in a second. So Roswell has part of its already built-in scripting, and a bunch of folks have already started going through this process of setting this up. Has leveraged uh, this installability of scripts to create a bunch of scripts for you. So if you want to install, say, run prove, which is proves running test manager for Common Lisp, you could just do run ROS install run prove, and it will actually go out and grab run prove. Actually, I think it's prove right now. It'll go out and then grab prove from Common Lisp and install it into your local directory slash bin slash uh, well, your .roswell slash bin folder. So that's the other thing I guess I should mention. When you're using Roswell, let me actually pull up another thing here. All your stuff for Roswell goes into this hidden Roswell directory. And I think this is regardless of platform. Okay, this is regardless of whether or not you're using um, uh, Linux or Mac or whatever. This is the same thing that you're going to end up using. All right. Um, uh, this directory structure is important to keep in mind just because, especially if you're moving or trying to do development in using Roswell, it's useful to know where your local project should be available so that Roswell can pick it up automatically. All right. The bin directory is where all the ROS install scripts that we were talking about, we'll go into. All right. If you want to use this, you can actually do one of two things. One way of actually running your script is actually running something called ros exec and run your command like this. Or you could do what I did, which is update your bash profile, your shell profile, and provide it the location of this directory, which is $home dot Roswell slash bin, and it will go into um, that directory to actually install those commands. And then since those are treated as executables, you can actually more than likely go into them and look at them, right? In fact, I think these are executables. They're not. Oh yeah, they're scripts. Okay, so these are actually scripts that'll get installed directly for you. Sorry, folks. We were having some technical difficulties there. Little blurb. I'm hoping for folks who are watching our live streaming, you are still with us. So where was I? Yeah. So the the other thing that I wanted to kind of mention is, and this is a kind of a step to actually build this. You could uh, once you have your command all set up here, you could actually go and install this fact your scripts directly into that folder by just simply uploading your script onto, say, GitHub, and it will download it from GitHub. So I was going to try and do this for AFP. So I have a public repository on AFP called um, github.com/Atlanta AFP fact. And I will just for folks, I will go ahead and run the commands to actually set up this repository. So first we need to go in and remove our executable, clean up some stuff here. Now we have what we want. Let's go ahead and do an initialization. Make sure our branches is all kind of like set up here. So we now added this git commit, first commit. Fortunately, now we have our branch is now master. So we can now go ahead and remote add origin it at github.com and p/git. And let's see, git push -u origin master. And we have our thing here. All right. So let's go ahead and see if this actually works. Because if I understood this correctly, all you had to do is just update your ROS file. It will go and take that ROS file to others and you can actually go in and deal with this. So one thing that I want to also point out is if you have a bunch of scripts and you just want to install them locally, you could simply move them into this directory called Roswell in in the repository, and it will, when you do a ROS list install, it'll go and grab it and install it appropriately in /bin. But the way that I thought it would be easier for most folks is to do what is suggested here, which is a system from GitHub. You can actually just provide, and it will just go ahead and grab it from GitHub for you. So here we're going to just go ahead and call Atlanta FP/AFP fact, and if I'm not mistaken, it should go and grab it from GitHub. and AFP fact is now available in should be available in our bin directory. Oh, actually, interesting. Wait, maybe I ran the wrong thing. Yeah, Roz install Atlanta hippie fact/fact. Let's see what happens. Where there's one step that I'm missing here that I'm going to have. No, that's one of the problems of doing a live demo. Sometimes you end up having these issues. Let me see. What am I missing here? ROS files should be located in the, and then if you are specifying in there, hold on one second. I must be doing something different than what Fukamachi has done for prove, because it does the same thing for prove. Got it. That's right. All right. I'm dumb. Let me do something here. Fact. Okay. Let's go ahead and make their. So the missing step is we have to move move fact Ros into Roswell. Now we have this get add Roswell, get commit mood script directory for update recognition by Quicklisp. Sorry, not by Quicklisp, by Roswell. And let's go ahead and push master into it. And we got it. There's a question, it looks like. All right. Let's see here. So now this should be updated. See if we got this all working. So Oz install. Let's see, did it recognize? Let's see this. Let me see if okay. So this means that I have to actually have a proper ASD file to actually get this all working. Okay. So for folks wondering what might be the issue here is there's a couple of things that need to be recognized by Roswell when you're trying to do custom extensions, like creating these kinds of tools to Roswell. One thing, especially when it comes to scripts like this, is there needs to be a Roswell subdirectory, as you saw earlier that I did with AFP fact, actually where the scripts should be located. And once you do that, then you can when you install from GitHub, it will recognize that in that case where the what's it it'll recognize that in the Roswell subdirectory of that project that there are a bunch of scripts, and it will install them accordingly into your bin directory. We could see another example of this is if we just install, say, ClackUp. You know, if we run ClackUp, it correct way to do it, right? No, it's install clack, sorry. What this is doing is install clack. It will actually also figure out from the Quicklisp system that the installed directory, which includes the source code, has a Roswell directory, and from that Roswell directory, it'll grab those Ros scripts and install them into .roswell/bin. Clack, for folks who are wondering what it is a web server that you can actually use and run uh, different applications. It actually is the web server behind, if you're right, has a replacement for, say, actually, I don't even think it's a replacement. You can actually use it as a complement to Hunch and Toot, which is Edie White's Clack. Sorry, Edie White's project. And but Clack actually ends up being a much larger. It will actually be able to handle more requests. Clack is actually the basis for things like Caveman and Ningle, which is Fukamachi's projects for doing web development. Those are web development frameworks that we could cover at some point. It looks like I'm going to have to create an ASD file for this, even though there isn't any actual systems, which is funny. I would be I'm a bit surprised that was necessary actually, but let's see what let me try one more thing, and if that doesn't is I'll postpone showing this off to next week when we actually do a more complete project. I run Fukamachi prove again. It should get it from GitHub, and it is compiling everything. And then it attempts to install that. So that seems to have worked. I do Atlanta fp/prove, not prove, sorry, AFP fact. What happens here? It can't seem to find it. Weird. This is a public. Let me try something else. Thought it was all lowercase would be fine, but maybe that. Nope, that's not it. Does Roswell install have a V? Maybe. Let me see. Oh, it can't. Oh. Um. Let me try one more thing, which is github.com https github.com the AFP fact, because it says that I could actually provide the GitHub repository from that. Weird. Looks like it's attempting to try doing multiple installs when it should be grabbing it from GitHub directly. All right. I'll go and take a look into this. This is kind of weird that it's not working as expected. I didn't expect that you need to create a system definition. It may be the case that if you only have scripts in the project, it's not going to allow you to actually have those, which is kind of, I guess kind of stinks if that's the case. But it may be just an extra a feature that needs to be added to the project. So we're going to continue since our time is kind of running out here. So I'm going to end it here. Next week, we're going to talk about a little bit more about Roswell's ability to set up different environments using Roswell, kind of like with virtual env. We kind of alluded to that with the fact that I showed you that you could install different Lisps with Roswell. And obviously, for folks who coming into Common Lisp and who have been checking it out, we know that um, what is it? You know that in Common Lisp, you can actually use these compile time macro flags to actually distinguish between implementations for different Lisp implementations to provide implementation specific code in your Lisp application. So we'll go and look into that a little bit more to set up your environment for that. And also next week we will start with talking about also continuous integration with Roswell as well. So that's it for today. One final question that seems to have been just popped up is about, do I plan to use ROS templates to replace make project? Okay, so ROS templates allows you to are separate for, I would say, um, uh, than setting up stuff using make project. So make project and Roswell are kind of complements to each other. Okay, when you're building your actual list project, you want to use ASDs or another system definitions. All right. What you use Roswell for is instead of say building your application with a main entry point with um, all the stuff in a script file that you built into ASD, which you can certainly do so, but it really isn't necessary. If you provide, some higher level API call that can be called from another main file, you can use the Roswell script to essentially provide a command line interface, or even if you want additional, application specific startup commands before start calling out to that main API function. So you could think of it you could think of it as a wrapper to your application. So your application becomes kind of an API that gets invoked through the Roswell script. All right. In this respect, Roswell then ends up serving two purposes. All right. One, it serves the fact that you now have kind of a cross Lisp um, build file that you could just simply run ROS build on and not have to think about the uh, Lisp implementation specific command line options to get a Lisp image dump. And additionally, you don't need to think about uh, what's it other stuff that you may have used during your development environment when you're trying to do a Lisp uh, save Lisp and die, because what you provided in the Roswell script is only that what you need to actually start up the script and start up the application, start up and building the executable, because you separated the concerns. I would say that it's more like a separation of concerns than anything else. The ROS templates, I would argue, allows you to create each of the, if you're using certain libraries for certain types of tools, you can create those scripts ahead of time, and that way you don't have to, have Roswell copy those around. And you don't have to, edit the default template every time. That's more important. You can actually just use the template as is for your specific needs. Any other questions from our stream?
Not really a question, but that seems really important. So,
Mm-hmm.
if I'm developing, then of course I'm defining all kinds of functions and making constants and things like that. So I want it would be useful if there were a good way to, I don't know, either to, again, I want to strip the tree down as much as possible. I don't want, like, the fact that I defined a variable to be 13 2 hours ago to be included somehow in a Roswell executable. Right.
So if you do ROS build separate from your running Lisp image, you won't have
Right.
that issue.
Okay, great. That's awesome. Good.
If you
I
if
mean,
it so your
yes.
running Lisp image is your development image, if you will, and then ROS build is your build system. All right.
Okay,
So
good.
that's kind of the way I would phrase that, you know.
That's great. That's great. I mean, it's not. I don't. I didn't think it was that esoteric of a problem, but as much as I play around with stuff, I don't want Judd's favorite dog showing up as a variable or something like that. So that's really good. That's awesome. I can trim a lot of definitions out of the space of what I'm running. Right. That's
Yes.
really good. Thank you.
Yes. Other questions? Feel free to add more to the YouTube comments and ping me. I'll be available on Functional Programming Slack if you have questions. And again, next week for folks who are eager, we will be covering the stuff on more advanced stuff on continuous integration with Roswell and using Roswell like a virtual env like environment for you Pythonistas that are coming out to Common Lisp, who are wondering what using Lisp, different Lisp implementations is all about. But that's all for next week. I will see you guys next time, and um, with that, I bid you guys all farewell. Thanks.
Thanks, Rom.